Um, you had a couple. Yeah, you want to do a few of these other questions real quick here? You said, what events does an El Nino? Can we measure it through observable phenomena? If you knew nothing about the data, how might you figure it out? The other indicator, well, record temperatures is the big clue. So, but there are other things that you can look at. Some indicators of uh, what's going on are severe droughts in Australia, malaria outbreaks throughout the world, like in the early 20th with El Ninos. El Ninos always brought malaria flare ups in India and Venezuela, Sri Lanka, Colombia. Uh, Other mosquito borne fevers spread like crazy. Rift Valley fever, dengue, you know. Zika is going to make a comeback. Zika's still around, and I freaked out over Zika in 2021 when that little mini outbreak happened in Brazil. But they're still living with the consequences of that. All those, for pregnant women, Zika is a huge. It feeds on the developing brain of the fetus. I mean, you get an encephalitic child. Uh, if when Zika hits the Gulf Coast without a vaccine, that's 20%. We could see typically one out of every five babies born being a Zika baby in 20 years. Uh, Weirdly, when warming up means fewer tornadoes in the Midwest. Uh, Actually, La Nina, we're getting a cold year this year. The La Nina, that typically La Ninas, we're going to see huge numbers of hurricanes. I mean, the hurricane forecast by Pennsylvania, University of Pennsylvania, just came out today. They're saying between like 29 or 26 and 39 named uh, hurricanes, and they're predicting 33. My God, the East Coast is going to get pounded this year if they're anywhere close to accurate. But probably fewer tornadoes in the Midwest, which is great. They're going to have baking heat and the formation of the Dust Bowl. Uh, they're going to wish for tornadoes. The other big clue, the other things are crop failures in India and northern China, which are actually happening now, same as in 1876. Uh, all climate changes, same question for all climate changes seen in the data. If this is asking what can we expect, then my answer is going to be same set of things I stress in my articles. Massively warming oceans, this is what we can expect for the next couple of years. Massively warming oceans, rapidly warming Arctic and Antarctic because the poles warm up first. The warming Arctic is really particularly bad because that acts as an accelerant on the burning boreal forests. Uh, this year, the just saw it last couple days ago. The wildfire season is already starting in Canada. Some of these fires that turned zombie fires and kept burning underground, they're breaking out already. Uh, by July, Canada is going to be just an inferno, the boreal forests. Probably Alaska this year too. 2022 was a bad year for fires in Alaska. They got lucky, weirdly, in 23. I think this year, not so lucky. We don't really know what's going on in Siberia, just except from satellite observation. They had 2021 was so bad, just off the charts bad. They've been when I say quieter, less, it doesn't mean there weren't any fires, but they were smaller than 2021, still bad. Siberia still burning. We've all been distracted by the war in Ukraine, but Siberia is still burning. And so 24 also going to be a massively bad year. The boreal forests are just burning down. I mean, they're going to all burn down. That's inevitable. They're in the ecosystem has already warmed up 4 degrees Celsius, right? Which that's a state change. That old ecosystem that all those forests grew in, that's gone. They can't survive a 4C change. So all of those spruce and trees and larch and pine, they're all going to die and they're going to be replaced by deciduous trees eventually. But what happens first is they all dry up and then they burn. That's That's a massive accelerant for us because those forests used to absorb a third of our CO2 emissions every year. Once they burn, their sponge absorption of CO2 obviously goes away, in addition to all the CO2 that they're dumping in the atmosphere as well. So we're about to see, even if we reduce our CO2 load by, uh, buying electric cars and putting up solar panels on our roof, even if we do that, doesn't matter anymore because the boreal forests are burning, and it's they're going to dump hundreds and hundreds. They could dump 150 parts per million in the next 20 years. I mean, that could easily push us up to 600. Just those forests burning. It's gotten out of our control. As those forests burn, that accelerates permafrost melt. Just saw a paper in Science News yesterday, a couple days ago, that measurements now show that the permafrost has turned from a carbon sink into a carbon emissions source. It's now flipped and is now actually releasing more carbon than is going. And that has to do with the winters. No winters means no snow, means that it's not everything that grew the previous year doesn't get compressed and frozen and stay frozen. It means everything that grew the previous year plus stuff that was below it previously frozen is now decaying and releasing carbon. As the winters in the Arctic get warmer, more and more of that carbon is coming out. That's more long term because it's going to take longer to melt. It takes longer to melt ice, right, than to burn a forest. But it's still that's going to play out over the rest of the century. That's potentially like 300 points of CO2 in the atmosphere by 2021. Again, that process already started. We don't have much control over it without doing geoengineering. Rapid drying out and desertification of the Midwest. Yes, the Midwest, Texas is. You got to write off Texas. You got to write off the big chunk of the Midwest. It's all going to turn to desert here in the next 20 years. It's if we were smart and we had a agencies and we were trying to figure out relocating people before it's a crisis, we would already be shutting down Texas. We would already be relocating all the critical industries. We would already be shutting down the places that are, the sacrifice zones, that there's no hope for them. They're gone at this point. They're dead and they just don't know it yet. Massive intensification of the hydrological cycle. Yeah, more heat in the equator means more evaporation, more water in the air means it fucking rains like crazy. I said a few years ago, we need a new class of storm that we call deluge class storms. Yeah, we're going to start seeing deluge class storms where not inches of rain, but we're going to be measuring it in feet of rain, how many feet you get in a storm. Our entire infrastructure is not built to handle that. I mean, we're going to see huge flooding in cities and communities all across the country, across the world, where things are just getting washed away. Massive hurricanes. This season is going to be crazy, crazy. Although it got downplayed last year and almost slipped people's notice, the one that hit Acapulco, right? It spun up from a category 1 to a category 5 in 24 hours. It spun up. Zero warning. Like they had maybe 3 hours of warning before it slammed into Acapulco because it spun up in 24 hours and hit them. Acapulco was completely devastated. I mean, like a military campaign went through and bombed the city, devastated last year. We kind of brushed that aside, It happened in Mexico, yeah, whatever. But when that happens on the East Coast, we'll know it. Massive fires across the Mediterranean and the increased desertification of Southern Europe. Yeah, Southern Europe, Spain, Portugal, Southern France, Italy, Greece, all of Southern Europe is just going to turn into desert and burn. Well, first it's going to burn and then it's going to turn into desert over the next 20 years. The process has already started. What phenomena most clearly shows the effects of climate change, assuming we couldn't measure anything with instruments? Okay, just assuming we had a communications network, a global, without measurements, we had just the global communications network, what would you expect to hear that was a signal that something was very wrong with the climate? The big tip off is the rapidly warming Arctic. When everybody in the Arctic is circle, start all the in Alaska, northern Alaska, and they're all getting on the phone and saying, hey, something's going on here. It's really, really warm here, and it's really been warm here for the last few years. That's the signal because rapidly warming Arctic means that's where all the heat goes, right? That means you're getting a lot of heat buildup and you're in trouble. Something is very wrong. Politicians don't push the baseline year of pre industrial temperatures to do something more current because they disagree with the science. They do it because they don't want to deal with the problem now. Yeah, that's true and not true. Some of them don't agree with the science. I mean, particularly the MAGA types, they don't want to agree with the science, so they're in denial. Really, uh, everybody thinks that they've got decades more because the moderate climate scientists, NASA, IPCC, all of them are still saying, oh, yes, we have decades. We have decades more to deal with this. We can do this gradually. We can do this through tax incentives and rebates and, or we can do it through the Inflation Reduction Act, the IRA thing of Joe Biden. We can target money to buy more solar cells and uh, build more, build out the grid. We can do this over the next. We don't have to do this crash program where we have to tell people, mandate things, and tell people you will do this, or we will fucking arrest you and throw you in jail, you asshole. No more rolling coal. No more of trucks like that. No more, you know, spitting on not funding public transportation. Yes, we are going to take your car away. Yes, we are going to tax the hell out of you to pay for this. Yes, your life is going to be changed. That's what's required. Nobody wants to deal with that. No, there's no political will for that. So we're paralyzed because not enough people understand what's going on yet. And so they won't support the things that we actually need to do. And the political class has basically said, hey, until that paralysis eases up and we can get enough people on board, well, we can't do anything more than sort of tinker around the edges and maybe kind of lay the groundwork for what we need to do. And that's what we're doing now, where everybody's waiting for the paralysis to break for, the average person to suddenly realize, oh yeah, we're in trouble here. What do we need to do something. Until that happens, I'm not optimistic on anything really big happening. Uh, is there any historical evidence that we can do integrations to fight off climate change? Um, yeah, we stopped the ozone layer from disintegrating. That was a really good thing, right? That was everybody came together and we worked as a team. Yeah, which is why you have to mandate. I mean, that's the role of government, right? It's supposed to mandate or to provide that kind of integration, make it possible for people to see how it all pulls together, and then provide a web of programs, right? That you can go from this, you can start your journey here and go tunk, 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 check the boxes. No, we don't have anything like that. No, nothing. And, you would wish for that, but we don't live in that kind of reality. Seven most important physical changes people should understand and what it would take them to revert to pre-industrial levels. Seven most industrial: massive increase in CO2, massive increase in methane, massive increase in sea surface temperatures, massive increase in air surface temperatures, changes in the hydrological cycle, more rain where you don't want it and less rain where you do, shifting agricultural zones. There are only like 6 to 8 bread baskets of the world. That when you look at them, those are like the optimal Goldilocks zones for growing the foods that we all use. And people say, "Oh, well, we grow food here too." Well, yes, every place grows food, right? And the problem is not every place grows enough food to support the population levels that are now exist, right? England in just before the state start of the Little Ice Age, right? After the medieval long summer, 400 years of good climate, England got up to about 8 million people. Okay. And then the Little Ice Age started, and in one devastating century, the population declined 50%. It got colder and wetter, and they couldn't feed 8 million people anymore. They could only feed 4 million. And so half the population died in 100 years, right? It can happen. That was one century. Because it played out over a century, the government, the feudal government at the time, was able to hold on to power. You didn't get complete collapse into just, chaos. There's the king still stood, the king, and the nobility stood, and they were able to fight off those peasant rebellions and keep order, and the social order was maintained, even though 50% of the population died. That's probably the if you look at a case study, if you want to look at a case study, sorry, my legs are cramping here. Uh, if you want to look at a case study, ow, serious cramp now. Ouch. I'm sorry. Yeah, I'm trying to knock this off here. If you want to look at a serious case study, England in at the start of the Little Ice Age is an example of what the maximum amount of population dieback and the rate that is survivable. I would say 50% over a century collapse is probably you can keep your civilization intact, right? Because that's you increase the death rate like 0.5% per year. And yeah, okay, a few more people are if it's this slow process. If it's 50% in 10 years, that's an entirely different kettle of fish, right? That's that's chaos. That's crazy war of everybody against everybody. Did you ever read are you familiar with Jose Philip Farmer's The River World books? Yeah, right. There's in one of the River World books, the an asteroid hits the planet, and 50%, half of the river, the food stations that were supplying everybody with food, they go dark and they stop working. And in one single horrible day, half the population crosses the river and goes to war with the other half of the population. And what the survivors, which are about 30% of the original total, survive, and they are the new baseline population. That's the kind of thing that happens when you have sudden massive decreases in the food supply. And that's an optimal case where these people, uh, whatever, they're not even growing food. They don't have to rely on this complex structured world of just-in-time manufacturing and global shipping and airports and parts getting here and all the computer chips being made in Taiwan and then shipped all over the world. They don't they had an optimal world where all of that stuff didn't have to work perfectly. We live in a world where everything has to work perfectly to maintain our civilization, particularly the production of nitrogen fertilizers, right? Nitrogen fertilizers go away, and most of us starve, 9 out of 10 of us starve to death. Uh, that could happen in a world of massive climate disorder. So we are walking on the edge of the abyss here, and it could happen really quick. Can we implement any fix if we can't prove the mechanism of the problem? Well, I would say we already know, we understand the mechanism of the problem. It's the CO2 levels. The short term problem is the drop in the SOx particulates. We can fix the SOx particulates, we can geoengineer, and we're going to do it. And that's just a given. The crisis is too intense. The pressure to do something about it to get some relief is going to be globally enormous. So yeah, we're gonna try, and they're gonna put sulfur dioxide back in ship fuels, and then that'll buy us some time, but not a lot, because like I said, the processes have started. we have to now, it's not enough for us to just to compensate for our CO2. Now we have to compensate for the burning boreal forests, for the melting permafrost, for all the other tipping points that we've triggered and are crossing. Everything now, 2023 was basically our tipping point year. Everything in the climate system now is working against us. Nothing in the climate. We've triggered all of the tipping points, and they're all going to start accelerating now. So to it's before we might have been able to get away with a small scale geoengineering problem solution. Now we're going to have to go with a big scale geoengineering solution. The techno optimists like Musk and the others, they're pushing solar management by putting a dust cloud in space using lunar dust to backscatter solar radiation. And everybody likes that idea because it doesn't have all the environmental effects that you will get from earthborne solutions. Like, nobody likes the idea of putting so much sulfur dioxide in the air that it literally turns the sky white. Elizabeth Colbert's book, Living Under a White Sky or Under the White Sky. Yeah, that's how bad the geoengineering will have to get. We will literally have to turn the sky white for over 100 years. A consistent year-to-year output of, say, 3 or 4 Pinatubo class volcanoes for the next 100 years and turn our sky white in order to solve climate change. We technically, that kind of project is doable. It's way more doable. Did you see the thing about Elliot Jacobson said, well, we only have to put mirrors on 1.6% of the world. Somebody on Reddit calculated that means like a 180-mile wide band of mirrors along the equator, running over the entire ocean part of the equator. This 180-mile band of mirrors is what that's talking about. Yeah, technically that's doable. I mean, it's certainly more doable than building 10,000 rockets and building a moon base and mining the moon for dust and then launching it into space to make a dust cloud screen. It's probably less costly and more doable than that. But really, that's do we really have the kind of international cooperation and coordination to build a mega project like that? But that's where we're at. It's that the only thing that is easily within our range that we can do is sulfur dioxide particulates. It's the only thing we can do, like, right now on the scale big enough to really help. So I would bet on that's where we're going to go. No such thing as optimal balance. What is the optimal balance for us? The optimal balance is the 1950 to 1980 climate. That's called the Holocene optimum. That's pretty much regarded as the perfect range of temperature for us in terms of maximizing food production around the world. 1950 to 1980 was the perfect climate for human habitation on Earth. That's what, if we were going to try and get back to where it was, that's where we'd go. 1950 to 1980 is already about 7/10 of a degree warmer than 1850. 1850 was cold by our standards. 1814, the Thames froze in London for the last time, and they had the last winter fair where the ice was deep enough that they could put stalls and booths and have a fair on the Thames in winter in London. That was the last time it was cold enough for that. But 1850 was still cold by our standards. I mean, pretty damn cold. 1950 to 1980, that's optimal for modern human existence. Why is it bad that the Arctic is warming faster? It's really bad because it shows that the models of the moderates were completely wrong. They predicted that it would warm up less than 2 times greater than it's warming globally. It's actually warming up 4 times greater than it is warming globally. So right off the bat, there you're saying they were wrong. They were hugely wrong. No, no, no. That's because of oh yeah, because that's going to trigger that triggers all of these things that they said, "Oh, you don't need to worry about permafrost melting. It won't get hot enough to do that." "Oh, you don't need to worry about the Arctic ice cap melting in the summer. It won't get hot enough to do that." We blue ocean event, pish tosh, that'll never happen. Yeah, now they're predicting it to happen in like 2035. And that's another accelerant, right? Because when all the ice cap melts in the summer in the Arctic, there is no Arctic ice anymore. All of that is now exposed water. It absorbs like 80% more heat than the reflection of the ice. So, and that ice that is exposed in the summer, it's exposed to massive, like 24 hours a day of sunlight, right? It will absorb heat, massive amounts of heat once the ice is gone. And that acts as an accelerant because then it warms up the Arctic like another half a degree in 10 years. And the warmer the Arctic gets, the more the gradient, the more heat, it levels out between you start up here with all this heat in the equator and it flows to the poles, right? And as it flows to the poles, we thought that the poles would just, the moderates said, oh yes, the poles will lose all that heat. The Earth has like an infinite capacity at the poles to radiate heat during the long winter months, right? Except that it doesn't have an infinite capacity to radiate heat because when it gets cold enough in the winter, it forms ice on the surface. And then once you get an ice pack, that seals in the heat in the water, right? So that's how you have life in under the Arctic Ocean. It's warm enough and it never melts, and it's right. So what happens is you start with all this heat at the equator flowing down, and instead of it just radiating away and this never going up very much, what we now know from the paleoclimate data is this will keep going up until you get to some new relationship between these 2 points, right? The flow of energy is what we perceive as climate, or as weather. I'm sorry, the flow of energy between these 2 points is what we perceive as weather. The long-term balance between these 2 points is climate. And our climate is about to change, right? It's going to get really hot, and the Arctic is really going to warm up. Not hot enough for alligators in the Arctic, but certainly enough to melt all the permafrost. Is there any proof that the permafrost release is bad? Yeah, well, yeah. More carbon in the atmosphere, that's bad.